Okay, I really like this question. How do we find the equation of a tangent to a unit circle? I'm going to assume that we need to find the tangent line equation. Equation of tangent line to unit circle. First, let's figure out what is a unit circle. A unit circle, believe it or not, is a circle. Let's see if I can get a circular shape. Maybe move that to the center here. Yep, so a unit circle is a circle that has a unit or as radius of 1. So that's 1. This is -1. And that's also -1. Here we have our x direction and our y direction. So the equation of a circle, equation of a unit circle, is x squared plus y squared equals 1. That's the equation of this unit circle. So, for example, this point here, that is 1, 0. That would be like x equals 1, square that plus y equals 0, squared 0, so that's just 1 equals 1, makes sense. Perhaps we have a line like this, and over here we'd have cos. Let's say that's 45 degrees. Here we'd have cos 45. Here we'd have sine 45. So our x value in that case, just to show how the a unit circle equation works out, example at point, let's say point P, and point P will have the values of cos 45, comma, sine 45. This would subbed into this equation over here. That would be cos 45, cos squared of 45 plus sine squared of 45 equals 1. And we know that cos squared plus sine squared of the same if their argument is the same is always equal to 1, so we know that this has to be right. So this is our equation for a circle, unit circle. This right here is what we set to the radius. Of course, we can make a bigger circle if we set this to a, like if this was 5, it would be a radius of 5. Okay, so that's a unit circle. Now, if we're trying to find a tangent to a unit circle, a tangent equation of the equation of a tangent line, we got to use some calculus. So a tangent line is essentially going to look like this. Let's see if I can get a line. Let's make this red, whole another color. So a tangent line is going to look something like that. Okay, a tangent line is going to look something like that, and we're going to try to find the equation of it. Now this should instantly get some gears turning in your noggin about calculus, because if we take the derivative of stuff, we can find the slope of the tangent line. If we find the slope of the tangent line, we can find the equation of the tangent line, as long as we know where a point that it occurs. And if we know that it's going to be to a circle, of course we can figure that out. We can just use that point right there. Okay, so let's take this circle equation and let's find the derivative to this. Okay, find derivative. let's say derivative with respect to x, because we're going to try to draw our lines in the same sense here. Find derivative with respect to x. And before we do that, we need to consider that y is a function of x. Meaning that when we take the derivative with respect to y, or derivative with respect to x of y, not only are we going to have if we just y by itself, we're also going to need to do this with the chain rule, because y is a function of x. So that means just taking the derivative by itself is not enough. We need to do the chain rule. So in this case, d by dx of just y by itself, that's going to be 1 multiplied by dy over dx, or it's just going to be y prime. Okay, but keep in mind we have to treat y as a function of x. And it will make sense in a minute. Okay, so let's rewrite this equation for the unit circle. X squared plus y squared equals 1. And let's take the derivative, or let's isolate y first. So we'll have y squared is equal to 1 minus x squared, and actually we can keep it like this. I think the calculus will be a little bit easier. So we're going to take the derivative with respect to x of both sides. D of dx of y squared equals d of dx of 1 minus x squared. Okay, so remember what I said earlier about y being a function of x? We're going to take the derivative normally, but we also have to multiply by its internal derivative. So this is going to be 2y multiplied by its internal derivative, so that's just going to be y prime, is equal to the derivative of 1, so that's just 0, minus 2x. Okay, so that's just negative 2x. Now let's divide both sides by 2y. Y prime is equal to negative 2x over 2y. The 2's cancel out on the top and bottom. They neutralize each other. So that is negative x over y is equal to y prime. Okay, so that's going to be the slope to the tangent line of a unit circle. Okay, and we're going to need to use that to help us find, that's going to help us find the equation to the tangent. So if we're trying to find the tangent, we found the slope. We're going to need to sub in the point x, negative x times divided by y. That actually makes perfect sense. Like if it's at the exact 45, you would expect the slope to be negative 1. As we get closer to x, this should get more steep, meaning that x is getting bigger and y is getting smaller. So its magnitude is getting bigger, but it's getting more negative. So that makes sense. And the same thing, if we go more towards 0, it should look something like this. If I draw a line, the slope, like right now, is like this. But if we go more towards 0, it's going to like flatten out like that. So x would be getting smaller and y would be getting bigger. So it would be getting smaller. So that makes sense. It's always good to think about the problems from multiple different directions. So we can cross-verify with different strategies, and if our cross-verifications lead to the same result, we know we are probably on the right track. Okay, so this is the slope, and to find equation to tangent line, we're gonna need to think about the equation of a line. So we know that a line equation is y equals mx plus b. And we're gonna typically want to solve for b. So let's isolate b by doing y minus mx is equal to b. And inside of m, we can sub in our derivative that we found previously right here. Right here. So that can be y minus x over y of x is equal to b. Or we can rewrite that as equal to a y plus x squared over y. This will be our b value. Okay. This will, or we should write this like y of a, x of a, to specify like this is a specific tangent line. Y of a, x of a, y of a, x of a, and these are this is going to be a particular point. Actually, I should not have compressed those two. I'm going to erase that. Or I guess the x's are going to be the same. Yeah, the x's are going to be the same. My bad. So I'm gonna erase this x. It's just like the y, the height of the height on the line, particularly, is not always going to be the same as the or never mind. What am I doing? I'm tripping. Yeah, we do need to keep them separate because the x and the y on the line are not always going to be the x and y of the circle. So this is going to be x a. Okay, so this is our b equation. If we sub this back into here, it'll make a lot more sense. And this is y of a. So y of a is equal to x over y, negative x over y, times x of a. So those are points on line, on tangent line. And that is those x and y's, let's say xc and yc, are points on circle. So we have that. That's our slope times our x of the line plus our b value. And our b value is this thing. Plus YA plus X over Y XA. Now, a general equation like this is going to be a little bit problematic to be solving, unless you set you're typically going to want, if you are asked to ever find the equation of a tangent line on a unit circle, they will typically ask you at a specific point, and you will need to sub in that point to these processes or to these equations to get it right. So there's no easy way to do like a general equation. Let's do a specific example of the slope of the tangent line, or equation of tangent line. Of tangent a line to circle at the point, we know one point that we certainly know that is on the thing is on the circle is cos 45 sine 45. Okay, so let's say we want to find the specific answer for this. So we can go to these equations, and we know that our x value is cos 45. We know our y value is sine 45. Okay, given that, we can make some subs into our equation right here to solve for b. I guess the xa and the subscript a and the other ones are going to be the same. So we know that we're looking for the base. And that's is equal to y plus x squared over y, right? Yep. We're actually going to compress the xa and the regular x because we're going to take these points into consideration for calculating the point. So we know that y is equal to sine 45 plus cos 45, all that squared, over sine 45. And we know that our m is going to be negative x over y, and we know that that is going to be negative cos 45 over sine 45. Okay, busting out my fancy calculator. Gotta set this to degrees. If I can find the button that does that. Awesome, found it. So if we have sine 45 plus cos 45 times cos 45 divide sine 45, that is equal for the base to be positive 1.414. It makes sense because that is, it's going to be, if we scroll up to our unit circle here, it's going to be higher than the 1 if we're taking it here. So that makes sense. Not necessarily too much higher, but just a little bit higher. So that lines up with our calculation of 1.414. Awesome. So then we can find our slope, which is cos 45 divided by sine 45. I believe that's negative 1. Let me just verify. Yep, it is just -1. So our final equation for our slope is y equals mx plus b. So tangent line equation at the point cos 45 sine 45. And I explained previously why those were points. We know that that is going to be like an equal distance away from, it makes a 45-degree angle, and if we're going to calculate the x component, it's just going to be cos. If we calculate the y component, it's just going to be sine of the angle. That's how we got these points to begin with. So the tangent line equation for a line that is tangent to this point is going to be y equals -1 times x plus b, which is 1.414. So that'd be our final answer if we wanted to find the tangent line to the equation the equation of the tangent line to the tangent line that intersects with the unit circle at an angle of 45 degrees, or the point that is 45 degrees away from the center, or the x-axis of the unit circle. Yeah, this one. Sounds Gucci? Sounds good. Okay. This answer is a little bit incomplete. Does not address finding the equation of a tangent line to a circle. Okay, gotta write that in as a question that I found to be incorrect.